Hello, everyone. Welcome to the Lead and Copper Rule webinar. Today's webinar will demonstrate the steps water systems can take to identify compliance sites for lead and copper tap sampling under the Lead and Copper Rule. The goals of the webinar are to provide systems with a better understanding of the requirements of the rule and how to effectively identify, select, and verify appropriate sites. Before proceeding with today's webinar, we would like to go over the following disclaimer. Briefly, the disclaimer states that the information provided in this webinar does not confer legal rights or impose legal obligations upon any member of the public. While EPA has made every effort to ensure the accuracy of the discussion in this presentation, the obligations of the regulated community are determined by statutes, regulations, or other legally binding requirements. In the event of a conflict between this presentation and any statute or regulation, this presentation would not be controlling. We will take a brief pause in case anyone would like to read the disclaimer in its entirety. All attendees are in listen-only mode for the duration of the webinar. Attendees can enter their questions into the questions box throughout the webinar. To ask a question, click the arrow next to questions in the control panel. This will open the questions box. Next, type a question in the box and click send. All questions will be reviewed and we will answer as many as we can at the end of the presentation. We will start the webinar with some polling questions. Please select the number of people in the room attending the webinar. We also have a second polling question. Is your home or residence served by a lead service line? Select yes, no, or do not know. We also have a third polling question. Do you have lead pipes or copper pipes with lead solder in your home or residence? Select yes, no, or do not know. Thank you for your responses. Our main presenter today is Kira Smith. Ms. Smith is an environmental engineer in EPA's Office of Groundwater and Drinking Water. She supports the Drinking Water Protection Branch as a co-lead for implementation on the lead and copper rule, as well as chemical and radionuclides rules. She previously worked for EPA on the 2007 lead and copper rule short-term revisions. In addition to EPA, she has worked as the Water Quality Regulatory Manager for the City of Houston, a regulatory consultant to several smaller utilities, and an engineering consultant for various projects in and around Tampa, Florida. She has a master's degree in environmental engineering from the University of California at Berkeley and a bachelor's degree in civil engineering from Union College. To help answer questions at the end of the presentation, Ms. Smith will be joined by Eddie Viveros. Mr. Viveros is an environmental engineer in EPA's Office of Groundwater and Drinking Water. He supports the Drinking Water Protection Branch as an implementation lead on the lead and copper rule and a supporting lead on the radionuclides rule. Prior to joining EPA, he was a consultant with Eastern Research Group, where he provided analytical support to the agency in the areas of wastewater management and chemical policy. He holds master's and bachelor's degrees in chemical engineering from Northeastern University. Now I'm going to turn the presentation over to Kira.
Thank you, Galen. Before I go over the presentation overview, I wanted to hop back and talk a little bit about the polling results because I think the attendees might be interested. In terms of those of you who had whether or not your home was served by a lead service line, 3% said yes, 75% said no, and 22% said do not know. And then for the question of whether individuals have lead pipes or copper pipes with lead solder in their home, 20% of you said yes, 46% said no, and 34% said do not know. I thought these polls would be interesting just to talk a little bit about how much we actually know and don't know. Even for those of you that are listening into this presentation that are interested in these things, think about all of the consumers out there that don't think about these things on a regular basis and how they might not know even more about what's in their home and what can get in their drinking water. So with that said, I do want to talk about the overview for this presentation. We're going to have a quick review of the current lead and copper rule, followed by discussion of lead and copper tap sample siting or tiering requirements. I am going to focus on lead service line and plumbing materials in these current requirements for this presentation. We'll then move into a discussion on resources water systems may use to identify and select potential sites. And lastly, we'll go over some methods of site verification. While these methods are not specified by the lead and copper rule, the rule does require all tap samples reported to the state include the tiering criteria under which the site was selected for the system sampling pool. Water systems with limited records may be able to use some of these field verification tests for more confidence that their sample sites meet the lead and copper rule criteria. Next slide, please. So the next few slides offer the brief overview of the current rule and the tap monitoring requirements for lead and copper. Next slide, please. Lead and copper both have health effects associated with them. Young children, infants, and fetuses are particularly vulnerable to lead because their bodies absorb these metals at higher rates than the average adult. In children, low levels of exposure have been linked to damage to the nervous system, learning disabilities, shorter stature, impaired hearing, and impaired formation and function of blood cells. Lead can also accumulate in our bodies over time, where it is stored in bones along with calcium. During pregnancy, this lead can be released and transferred from the mother to the fetus, resulting in premature birth and reduced growth. Adults with kidney problems and high blood pressure can also be affected by low levels of lead more readily than healthy adults. For copper, some people who drink water containing copper in excess of the action level may, with short-term exposure, experience gastrointestinal distress. Long-term exposure to copper over the action level may lead to liver or kidney damage. Wilson's disease, which is an inherited disorder where copper accumulates in the body's tissues, can damage the liver and nervous system. Next slide, please. So lead and copper enter drinking water through the corrosion of materials in the distribution system and household plumbing. As you can see in this infographic, common sources of lead and copper include service lines, solder, pipes, faucets, and fixtures. The lead and copper rule aims to reduce exposure risks primarily by reducing the corrosivity of water. Next slide, please. The lead and copper rule applies to community water systems and non-transient non-community water systems. So transient non-community water systems are therefore not subject to the requirements. The population served by the water system is a factor in determining the applicability and timing of certain rule requirements. Under the rule, large water systems are those that serve more than 50,000 people. Medium systems are those that serve more than 3,300 to 50,000 people. And small systems are those that serve 3,300 or fewer people. I do want to note that the recent proposed lead and copper rule revisions included small systems as those that serve 10,000 or fewer people. These revisions, however, have not been finalized and may be different in the final rule. Next slide, please. The lead and copper rule established maximum contaminant level goals, or MCLGs, of 0 and 1.3 milligrams per liter for lead and copper respectively. MCLGs represent the maximum level of a contaminant in drinking water at which no known or anticipated adverse effect on the health of persons would occur, which allows an adequate margin of safety. They are non-enforceable goals that only consider public health. They do not take treatment technology or method detection limitations into account, so they are sometimes set at levels that cannot be achieved by water systems. Because lead and copper in drinking water is often the result of corrosion occurring in customers' homes, EPA established treatment technique requirements instead of maximum contaminant levels, as are used for other contaminants that we regulate. The required treatment techniques include corrosion control treatment, source water treatment, a lead service line replacement, and public education. Whether a water system must conduct these treatment techniques is determined by an action level. If more than 10% of tap water samples, or in other words, the 90th percentile, exceed the lead action level of 0.015 milligrams per liter, or the copper action level of 1.3 milligrams per liter, a water system is triggered into conducting the required treatment techniques, as well as biannual or standard monitoring. It is important to remember that an action level exceedance does not mean a system is in violation. Violations for the current lead and copper rule occur for failure to conduct treatment technique requirements. Next slide, please. So the lead and copper rule requires the collection of lead and copper tap samples from a minimum number of sites. Systems must collect one sample for lead and copper from the number of sites listed in this table. As you can see, the number of sites is based on a water system's population. Tap samples must be collected every 6 months under standard monitoring, or annually or triennially under reduced monitoring. The frequency is generally determined by the system's 90th percentiles. Systems at or below both action levels are eligible for reduced monitoring, while those exceeding either action level must continue to conduct standard monitoring. Samples are collected from January to June and then again from July to December under the standard monitoring. While systems eligible for reduced monitoring collect samples from June to September unless the state has approved a different 4-month monitoring period. Systems that qualify for reduced monitoring, as you can see in this table, can reduce both the frequency of sample collection as well as the minimum number of samples. To ensure a sufficient number of sites are available for sampling, it is beneficial for water systems to identify more sample sites than the required minimum. Also, remember, the state may have requirements for a certain number of alternate sites available in a site sampling plan or pool. Next slide, please. So let's take a moment to look more closely at the lead and copper rule sample site criteria requirements. Next slide, thank you. So what are the criteria for sites under the lead and copper rule? Well, the tiering criteria intend to prioritize sample sites according to where the highest risk of lead exposure would occur. These tiering criteria take into account whether a system is a community or non-transient non-community water system, the presence of lead in service lines or premise plumbing, and the building type, for example, a single versus multifamily structure. Compliant samples must be collected from the highest risk sites that water systems identify based on this criteria. Next slide, please. Current rule sets up 4 tiers for community water systems. Tier 1 includes the highest risk sites, and representative sites include the lowest risk of lead and copper exposure. Tiers 1 through 3 include lead service lines and or premise plumbing with lead pipes and or copper pipes with lead solder. Representative sites are focused on plumbing materials commonly found throughout the water system. As I mentioned previously, this webinar is going to focus on identifying service line and plumbing materials for appropriate sample sites and not necessarily focus on the dates that are in the current rule. However, these are the current requirements systems must comply with today. So for community water systems, Tier 1 sites consist of single-family structures that contain lead pipes or copper pipes with lead solder installed after 1982 and or are served by lead service lines. Tier 1 sample site criteria consists of single-family structures unless the system has more than 20% of the systems they serve made up of multifamily residences. Then they may include multifamily in the Tier 1 criteria. If a system contains lead service lines, the current lead and copper rule requires half of the samples to come from sites served by a lead service line. If an insufficient number of lead service line sites are available to meet this requirement, the system must collect what samples it can from available sites with lead service lines before it can move on to sampling from the next highest tier. Tier 2 sample site criteria consists of buildings, including multifamily residences that generally meet the same criteria as Tier 1 in terms of materials and lead service line. And again, the plumbing materials would be those installed after 1982. The Tier 3 sample site criteria just consists of single-family structures that contain copper pipes with lead solder installed before 1983. And again, if water systems cannot collect enough samples from tiered sites, they must collect the remainder from representative sites. A representative site is a site in which the plumbing materials used at the site would be commonly found at other sites served by the water system. Next slide, please. For non-transient, non-community water systems, the current Tier 1 sample site criteria consists of buildings, whether single or multifamily, that contain lead pipes or copper pipes with lead solder installed after 1982 and or are served by lead service lines. Similar to community water systems, if the system contains lead service lines, the current rule requires half of those samples to come from sites served by a lead service line. If an insufficient number of these sites are available to meet this requirement, the system must collect what samples it can from available sites with lead service lines before it can move on to sampling from the next highest tier. The Tier 2 sample site criteria consists of single or multifamily buildings that contain copper pipes with lead solder installed before 1983. Note, Tier 3 sites do not exist for non-transient, non-community water systems. And again, if the water system cannot collect enough samples from tiered sites, it must collect the remainder from representative sites, again, those commonly found at other sites served by the water system. Next slide, please. So the previous section showed how many samples water systems must collect and the criteria for selecting sample sites. Next, we'll describe how to locate and select the sites for this required sampling. Next slide, please. So as we discussed in the previous sections, this rule site selection procedures focus on high-risk sites and are designed to identify system-wide corrosion issues. The high-risk sites also provide a more conservative estimate of a system-wide lead and copper levels, and help ensure that corrosion control treatment is provided at levels that adequately protect public health throughout the system. Samples must be collected from taps that are used for human consumption. In residential buildings, this might mean a kitchen or bathroom tap. For residential buildings, this includes interior taps, such as drinking water fountains or kitchen or food prep area faucets. Sampling must not include entry points to the distribution system, hose bibs or utility sink taps, or faucets that have point of use or point of entry treatment devices designed to remove inorganic contaminants. Again, to ensure sufficient number of sites are available for sampling, systems are strongly encouraged to identify more sites than the required minimum. This will help mitigate against gradual losses that inevitably occur over time. This might include homeowners that just decide to say they don't want to participate anymore, won't let you sample their house, or sites become ineligible because lead service lines do get replaced, and therefore sites that were Tier 1 are no longer Tier 1. So these are some steps to help water systems ensure they have appropriate sites. The first step is to find the age of all homes and buildings in the system. Oh wait, we're on the next slide. Sorry, Galen. Okay, here we go. Here's the site selection process. First, find the age of all homes or buildings in the system. And again, this is just some best practices. This is not required or recommended by EPA. These are just recommendations or just some awareness of best practices. So finding the age of all homes and buildings in the system can be done with the assistance of county offices, typically property appraisers, or real estate companies, or simply by using an internet search. Age of homes is important because the 1986 amendments to the Safe Drinking Water Act enacted a lead ban, making it illegal to install lead service lines or use lead solder. Most states adopted and enforced this ban by 1988. This is how EPA determined the dates in the current rule tiering criteria back in 1991 when this rule went final. Homes built between 1983 and 1988 were the most likely to have the newest lead-bearing plumbing components and therefore the most likely to leach lead into water. Also, knowing the year of construction or replumbing can provide insights into the materials in the home. Next, check to see if there's any state, municipal, or local plumbing codes that ban lead service lines or lead plumbing from being used. This could dictate where or if lead service lines are present in the system. And then review different data sources, which I'll talk about a little on the next slide, such as maintenance records and distribution data to identify new sites, as well as reevaluate and update potential sites. And then lastly, confirm or verify the sites. Next slide, please. So these are just some typical data resources that systems can use to reevaluate and update sites or add new sites to their sample plan, including building department plumbing codes, permits and records, inspection and maintenance records. Recent repair records I've found can tell you a lot about what's actually out in the system today, as opposed to what an old record might tell you. Distribution maps and drawings are always useful. Meter installation records that should have a record of what the material is on both sides of the meter in terms of a service line. And if there is a lead service line inventory, that is always a really good resource. Other sources can include capital improvement and master plans, standard operating procedures, operation and maintenance manuals, and existing water quality data. The list goes on, but these are just some resources. Next slide, please. So the lead service line or materials evaluation. Under the current rule, all water systems were required to conduct a materials evaluation. This evaluation helps systems identify sites for their sample pool and classify them according to the rule-defined tiers. Although not currently required, it is beneficial to update the evaluation periodically. This ensures high-risk sites continue to be targeted in accordance with rule requirements. Now, materials evaluations are going to be covered in more detail in the webinar scheduled for next week on September 23rd, focusing on using these materials evaluations to develop proper sample pools. On this slide, we have included worksheet number 1 that's in Appendix D of our 2010 monitoring and reporting guidance. It provides a format water systems can use to document information about plumbing materials in specific buildings. It is generally beneficial to document the type of structure, whether it's single or multi-family home, location and contact person for the site, whether there are lead service lines, what lead and or copper bearing materials are present in the plumbing and the year they were installed, whether the presence of these materials has been verified by the water system, whether the site was selected as a routine or optional site or as an additional site when needed to compensate for ones that are no longer available, and whether the owner has been trained on how to collect the sample. Next slide, please. Previous section showed how many samples water systems must collect, as well as the current rule tiering criteria and data resources to assist in locating and selecting sites. Next, we're going to talk about some current options available to confirm or verify sites to meet rule requirements. Please again note, EPA does not have specific requirements or recommendations for site verification methods. The next slide summarizes, or the next few slides summarize practices currently in use by utilities and are provided for awareness purposes only. So here's an example of some of the fields filled out in the materials evaluation worksheet 1 that we showed earlier. As shown, site verification can include specific documents, such as a repair record that they confirmed was a lead service line. Other field tests can also be used. Sites with similar characteristics, such as proximity and year built to sites with confirmed lead service lines, might also be something states would accept for verification. Resident or landlord could conduct a scratch test on interior plumbing to verify the presence of lead pipes. This might be something public water systems include with training materials as part of a survey or even as part of their compliance sampling. So once sites are identified as part of reviewing data resources, field verification is a tool to help systems ensure they meet the lead and copper rule tiering requirements. So this slide is similar to a typical food establishment review website, where you have a dollar sign to to indicate something is not expensive, and as the dollar signs increase, it becomes more and more costly. In addition to cost on this slide, the dollar signs also represent increases in needed skill, complexity, and possible disturbance to the resident. For this reason, excavation is typically not economical or potentially health protective to use for single site verification purposes only. Typically, utilities remove any uncovered lead service lines once they're excavated, as opposed to covering them back up. But we'll talk about that in later slides. Next slide, please. So let's talk about some basic tests anyone can do. Those of you that said they didn't know, 34% of you said you didn't know if you had lead pipes. You can conduct a scratch and or magnet test to try to find out. Lead pipes and service lines are generally this dull gray color in the picture, and they're very soft. You can identify them by scratching carefully with a key or a coin. If the pipe is made of lead, the area is going to turn this bright silver color, as you can see here. Don't use a knife or other sharp instrument, and take care not to puncture a hole in your pipe. And another way to try to tell if it's a lead or copper line is a magnet won't stick to lead or copper. So if there's a scratch test and then you try to stick a magnet on this pipe, you'll find that the magnet won't stick because it is lead. One issue that one of my EPA mentors pointed out to me is that with these types of tests, they're not going to identify any galvanized pipes that have interior lead lining. These are just going to tell you what's on the outside and not necessarily what's on the inside. Next slide, please. Similarly to tests that can only tell you what's on the outside, swab test kits have been used for lead-based paint detection for a while. And EPA actually has approved certain kits. The way this works is the swab changes color after contacting a lead surface. It, again, just tests what the pipe is made of on the outside and not the water or any lead lining that might be on the inside. These are available at local hardware or home improvement stores, or as I'm sure everyone knows, on the internet. They can be purchased and delivered to your house. You should look for an EPA recognized kit. These are listed on our website, and I have them here, a screenshot of them on this slide. I do need to mention that trade names or commercial products that we mention do not constitute EPA endorsement or recommendation for their use. Next slide, please. So let's talk about using sampling to try to verify sites. The current compliance sampling is first draw, as you see here, and I have the citation to where you can find it in the Code of Federal Regulations if you like to look those things up. Generally, these should be 1 liter in volume. It needs to be cold water from an interior tap that's used for consumption, and it needs to have sat for at least 6 hours without being used. A lot of utilities and or local health departments will actually provide sampling and analysis according to this protocol or similar upon request for a fee. You can also contact a local laboratory that has certification, and they will also send you a bottle with instructions and test your water for you for a fee. The figure here is a presentation from our EPA Office of Research and Development staff. From a presentation they gave at the 2019 AWWA Water Technology Conference. It shows the first liter sample labeled 1, that's purple, might only reveal lead or copper materials in home plumbing. It most likely will not confirm the presence or absence of a lead service line. As you can see, the orange shows the service line, and the liters that are orange aren't being analyzed for first draw samples. Next slide, please. This is an option that some utilities have implemented. It is not, again, an EPA recommendation or rule requirement. For this method, a 1 liter sample is collected after 4 liters of water have flowed through the faucet, and it's depicted in this figure as the orange bottle labeled 5. This does increase the likelihood that the sample is from water in contact with a service line instead of interior plumbing. A downside to this type of sampling is that Fifth Draw does not always definitively provide a sample from the lead service line. There's variability in terms of length and size of service line from main to meter and meter to tap within systems and between systems. Utilities might wish to target lead service lines based on comparing their field results and typical configurations for their particular system. Next slide, please. This is also an option that some utilities have used, not an EPA recommendation or rule requirement. Sequential sampling involves taking a set of samples, collecting the water one right after another. So in this figure, all 10 of these liters would be collected and analyzed. The intent is to capture all the water in the plumbing from the kitchen tap to the water main. This is a little more expensive because instead of 1 or 2 liter samples, you're asking for 10. Keep in mind the volume for sequential sampling doesn't have to be 1 liter. It actually might not be appropriate to detect sources of lead or copper in smaller homes and or with shorter service lines. And so consider other unit volumes. A typical one is 250 milliliter as appropriate. Also, I do know that EPA researchers are looking into flushed samples to identify lead service lines, which may be a viable option to consider. There's a lot of information out there. Next slide, please. So excavation. This a method of hydro vacuum, otherwise called some refer to potholing. These use pressurized water and a vacuum system to expose the underground infrastructure. This can result in less disruption to a homeowner than an open cut or sequential sampling even. It does require a skilled crew and is moderately costly. It's also moderately accurate. In talking with those more experienced than I with this method, the accuracy depends on the number of holes and how many patches to the line. So you would want to have, it looks like in this picture, these gentlemen are at the curb stop. You might want to have another sample or another hole closer to the meter. And then on the other side of the meter, the homeowners will let you to see what exactly is under the ground. Next slide, please. So the traditional excavation of open cut is probably the most accurate way to determine if there's a lead service line because you would uncover the line. It is highly disruptive to residents. Now, to offset the results of disturbing a service line, some utilities provide point of use or pitcher filters that are third-party certified to remove lead and other inorganic contaminants. As mentioned previously, water systems would typically replace any lead service lines in the field when uncovered during excavation. It's not economical to place the lead service line back in service and cover it, only to come back later to re-excavate and remove the line. Again, this is not an EPA requirement or recommendation, but just an observation. One thing that this may be useful for systems that are conducting lead service line replacement or just trying to update their materials inventory is that it can potentially identify analogous sites. Say that these folks here in the picture are excavating because there was a leak and they get down to repair it and they find, oh, it's a lead service line. Oh no, let's replace it. Well, consider all the houses on the line are served by the same water main, and if they were all built around the same time, especially by the same construction company, chances are good the rest of those homes have lead service lines. One of the newer things I've seen that's interesting to me is you can also use these to calibrate predictive models that can be used to try to target other locations throughout the system. These models sometimes use what's called machine learning, because as you verify more sites, the smarter the predictions get, and it's fascinating. So next slide, please. So in summary, lead and copper enters drinking water through corrosion of materials in pipes and plumbing. Common sources of lead and copper include service lines, plumbing pipes, solder, faucets, and fixtures. Lead and copper rule reduces exposure risks primarily by reducing the water's corrosivity. The current lead and copper rule sample site requirements include those sites with lead service lines and or lead pipes or copper pipes with lead solder as part of interior plumbing. Next slide, please. Oops. There we go. Site selection includes determining the age of your sites, local codes that may guide what kind of materials are used or have been used, data resources that include utility records and maps and documents such as that. Some field verification practices in use are swab and or scratch and magnet tests, sampling for straw or other options, and then excavation. Again, that typically results in immediate replacement of lead service lines. Next slide, please. Here are some references. The presentation I alluded to by our Office of Research and Development folks can be, assuming that PDF links work, in the handouts that you'll find the presentation slides. You can check out that presentation. I recommend it. And then our 2010 revised lead and copper rule monitoring and reporting guidance is available on our website. Next slide, please. So now we are going to move into questions. And we have a lot of time.
Yeah, we have some great questions, and you guys can continue to type in your questions as we start the Q&A session. So Kira, our first question is, how does a customer know if the solder in their home has lead in it or not?
They don't. I'm not sure if a swab test might detect that, if they can actually see where joints are soldered together. Otherwise, you know, they can look at when was their home built? Do they know if they have copper pipes? If it was built before kind of the state enacted the lead ban of 1986, which could be anywhere from 1987 to 1989, I think, depending on the state. They may have it. Unfortunately, it's really one of those things that's hard to know.
Great, thank you. And our next question is sequential sampling acceptable for identifying lead service lines?
That is up to the utility in the state. It can be used to say, wow, we're seeing a spike in the lead results in the 5th through 8th liter. We think it's a lead service line. You know, they should kind of look at other information about the site in terms of when was it built? Are there other indicators that there is a lead service line? But again, that's the EPA doesn't have a requirement for that. That's up to a state.
Great. And are there swab test kits for copper too, or are they only for lead?
That's a good question. I don't know the answer. I don't think EPA has approved a swab test kit for copper, if there is one, but that doesn't mean it doesn't exist.
Great. And how can a person guarantee in the current sampling method that there is no residual hot water left and a pull-out faucet that has a hose, since only the cold water is required to be sampled?
That depends on the plumbing, honestly. I don't know the answer to that. I'm not a plumber.
All right. And we have another question about, so you mentioned that finding a lead service line at one home could be an indicator that other homes served by the same water main also have a lead service line. So do you recommend the same logic when the service line is not lead?
It certainly could be applied that way.
Mhm. Great. Okay. Our next question is, why are multifamily buildings with copper plumbing and lead solder constructed before 1983 not prioritized ahead of representative sites or included in Tier 3?
They are. That's tier 2 for non-transient systems. Oh, I see what you're saying. That I don't know the answer to.
Hey, this is Eddie. I think I can take a crack at this one. I think that the person who's asking this question is asking with regard to community water systems. You know, like Kira said, there's a tier 2 that includes multifamilies, and that's after 1983. Multifamilies built after that. Why not include it before 1983? My read of that and how they laid out the tiering requirements when they first promulgated that part of the rule in 1991, it hasn't changed since, at least thus far, is that at the time in 1991, you know, the engineers had done the math and realized that 1983 was a sort of cutoff point where the amount of lead that could come from the lead solder was appreciable, I'll say. And so that wound up being the cutoff. For whatever reason, but bearing with that, then as you work your way through the tiering, right, highest risk site, lead service lines tier 1, multifamilies are in tier 2. It would just seem to me that at the end of the day, you know, a site constructed before 83, multifamily, it might not really fit as a high risk site because, again, at the time, it would have been more than the 8 years that was the cutoff at the time in 1991. And because it's a multifamily building, they've got that extra water running more frequently. It's harder to get the same level of stagnation as you would get at a single family site of the same kind. So hopefully that helps.
Thanks, Eddie.
And we have another question about multifamily residents being Tier 2 sites. So it would appear that these residences would expose more people to lead contamination than single-family structures. Is the tier classification based on the probability that more water will be in constant use and thus might be better flushed instead of the apparent risk to more individuals?
Short answer is yes. This is just essentially the same as the question we were just talking about before, that, you know, while true, there are more people at multifamily residences, it's important, though, to be mindful of the plumbing, and the water in a multifamily residence tends to move more frequently compared to a single family structure.
Great, thank you. And can you provide an example of what a representative site might be?
Sure. New systems that might have been built, you know, in the late 90s or 2000s might have PVC. And while PVC is maybe not a good example because you could collect a lead and copper first draw for 1 liter. I guess, you know, the home plumbing comes into account, but, you know, if that's what your whole system is, that's where you sample. So again, in Houston, we had a lot of copper pipes, not necessarily installed before, you know, 1988, but new copper. You could pick sites and say, you know, 70% of my system is copper, new copper, so I'm gonna, you know, 70% of my sites, of my representative sites would be copper. It just depends on how the system is, what's the materials used in the system.
Okay, great.
This is Eddie. If I could piggyback on that, another example that we can find from time to time of representative samples are water systems where all sites have water softeners installed. And so in a case like that, we know that point of entry devices and water softeners, generally speaking, are something to be mindful of when we collect samples for lead and copper, because it can mask the contributions of lead. But in a case where they're all plumbed in and every single site has that softener, that would be considered a representative site.
Okay, great. And for very small systems where finding 5 sampling sites might be a challenge, is it acceptable to use a utility sink as a sampling site, or is it preferred for an exception to be granted so that less than 5 samples are okay?
I do believe that the federal rule allows systems to take fewer than 5 samples. It's just when they exceed the action level that they need to collect 5. I'm not aware of anything in the rule that says you can't take, a site at one location one day and then take another sample from that site the next day, and have those 2 count towards the 5. Again, that depends on states. I would avoid using a utility sink, especially if it's one where you could even run into like cross connection issues where you've got a mat up, it's full of like dirty water and a dirty mop kind of thing. I guess it depends on the utility sink. Do people drink out of those? That would be the question the system should ask. Would I drink out of that? Well, no, so it shouldn't be included. Or, oh, it's pretty clean, I guess it could be okay. That's one of those case by case.
Yeah, this is Eddie. Be mindful too, right? At some point you communicate the results. And so odds are pretty decent. While I have no crystal ball and I can't predict the future, odds are decent that a utility sink with stagnant water will come up high for lead, in which case that's something you're going to have to figure out in terms of the communication, right? We found high lead levels. Oh no, where did you find it? In the utility sink. Oh, is someone drinking from that? So, those are all things to be mindful of. At the end of the day, as far as the regulation is concerned, we're talking about taps that people consume water from.
Okay, great. And the next question is, if a water system has lead service lines in its inventory, is there a requirement to have 50% of their sample sites representative of lead service lines?
So the requirement is, say a system needs 100 sites and it's got lead service lines. The requirement would be that 50% of the sites, or 50 sites, if they have to have 100 sites, would need to be lead service lines. That's the current rule requirement, at least 50 sites out of 100. I'm not sure if that's what the question really is, but that's the current requirement.
Okay, great. And what is your advice on a water system that only has homes with softeners for LCR compliance? For the scenario that most homes have softeners, can we collect multiple samples from a site without softener?
Well, I think Eddie answered that question earlier. If all the sites have softeners, then that's your representative site.
Okay, great. And we have a question about how the 1982 date determined as a cutoff point for Tier 1 site about how the 1982 date was determined as the cutoff point for Tier 1 site determination for Tier 1 sites. They're wondering why can't homes built before 1982 with lead service lines fit into the Tier 1 category? Because right now they fit into Tier 3 when they have copper pipes with lead solder.
So that's kind of 2 questions. One being, the dates don't, for the current rule, apply to sites with lead service lines. Lead service line sites can be tier 1 sites. It doesn't matter when they were built. If you have a site that's a lead service line and it's a single family home and a community water system, it's a tier 1 site. If you put it that way. The date, I might have gone through this a little quickly in the presentation, but at the time in, well, 1987 when the rule was proposed, and then 1991 when it went final, 1982 was kind of the cutoff where the folks there thought after 1982 we'd have the newest lead and copper installed, and the new metals tend to leach more than old metals that have actually been in the water and had a protective film develop on the walls. So at the time it was considered the newest, after 82 was considered the newest lead, newest copper. That's why that date. But there's nothing in the rule that says that you have to have, that lead service lines have to, apply to before or after 1982 or 1983.
Okay. And we also have a similar question. Wouldn't you want to sample from a pre-1983 site with copper pipe lead solder rather than post-1986 homes with plastic plumbing?
Well, I think you're comparing a tier 3, which would be what they described, right? They said a copper pipes with lead solder before 19. Can you read the question again? I'm sorry.
Sure. So it says, wouldn't you want to sample from a pre-1983 site with copper pipe lead solder rather than post-1986 homes with plastic plumbing?
Yes, you would, because that's a tier 3 site versus what might be a representative site. And the rule requires you sample from the highest risk sites.
Okay, great. And Eddie, did you want to take a look to ask any more questions that are remaining?
Sure. I'll start off with a softball one. It looks like folks are asking if they can have a copy of the PowerPoint.
And that's in the handouts tab of the GoToWebinar panel.
Okay. Someone asked if there's been any data analysis or studies to determine if a home's lavatory tap is at higher risk of having a lead exceedance versus the home's kitchen tap or vice versa. Kira, I'm not sure if you might happen to have one in your back pocket.
What is the question again?
I think as I'm reading it, it's any data or analysis to show whether kitchen versus bathroom tap would be higher in terms of lead exposure, or the other way around.
I am not aware of a study that looks into that. It's hard to even know, was it a bathroom or kitchen sometimes. When you get a sample bottle, sometimes it's just a, did the customer, click the right box, and the box might be, oh, did you collect this from a bathroom or a kitchen? Yes. So it'd be hard to probably look into a study like that, but I'm not aware of any.
Yeah, the best I've got, folks, for the person that asked the question, is just anecdotal. I do think at the end of the day, it just depends on the plumbing of the house and inferring from it the site conditions as best as we can. Granted, none of us have X-ray vision, which of course is what makes this such a challenging rule. So this anecdote was basically someone went and visited the house to take a sample, and the customer requested to collect a sample both from the kitchen and the bathroom. And so at the time it was like, oh, we can take one, it should be representative of both. And I had heard from this story that the homeowner really appreciated the opportunity to get their bathroom tested. They had 2 little kids brushing their teeth. They just wanted to make sure it was all kosher. And sure enough, actually, when all was said and done, the results coming out of the kitchen were lower than the results that came out of the bathroom tap. And it turned out that in that particular home, the plumbing had been renovated more recently for the kitchen. And so in that case, to the question of which one's higher, this one or that one, it really can boil down to case specific matters. In that particular home, it turned out to be the bathroom because it had the oldest plumbing.
Great. And we do have a few questions left, but we are at time. Should we go ahead and wrap up?
Yes, I think we do need to wrap up.
So I'll pass it back over to you, Kira.
Well, thank you everyone for your time. If you have more questions, please contact myself or Eddie. Here's our contact information on the screen. And this is in the handout as well, this information. So please download the PDF if you'd like to keep this information.
Great. Thank you so much.
Thanks.